Hi, ladies and gentlemen. This is Mr. Green, and I'm making this recording because I'm going to be teaching next week. Actually, going to be giving the test for the STAR test for the younger kids, so I'm not going to be able to be in Class Connect. So I wanted to make certain I got this recording out to you. Okay, What are we looking at? Well, we're doing trig applications, which is Unit 5, and there's some interesting things in that one. We've already done the law of sines and the law of cosines. So we're going to be taking up vectors today. Vectors, you read the lessons and this all seems really pretty easy stuff. I mean, a vector is nothing more than looking at an x and y coordinate here. It's just that direction there, okay? But you can figure out the magnitude and the angle that it's going out at. And that's what you normally write the vector as the magnitude and the angle of the vector going out. Well, you can find the magnitude of a vector by knowing the point on the vector. Okay, knowing the endpoint out here, or just a point on it, you can figure out the magnitude simply by using the Pythagorean theorem. X squared plus y squared equals, that hypotenuse squared, because there's your y and there's your x. I mean, it's real easy to see that. And then you just got this angle that you're dealing with there. I mean, you can just say the vector is going out at this magnitude, going in this direction, and so forth. But that's the easy thing about vectors. Okay. Then they throw a couple of terms at you. One of the terms they throw at you is this orthogonal. Orthogonal simply means perpendicular. Don't get confused by it, okay? So if two vectors are orthogonal, then when you multiply the magnitudes, you're going to get 0. If they're not perpendicular, you will not get 0. It's really not that difficult to do. All you got to do is find that magnitude, multiply them together, and see if they're going to be equal to 0. So if it asks you, are these two orthogonal? Well, let's see here. Multiply their magnitudes together and see what we get. Okay? So when you're looking at the angle that two vectors might have, so I've got here x and y coordinate, I've got a vector going out this way and a vector going out this way. And I'm wanting to know that angle right there. Okay? There is a way of doing it, and it involves using the dot product. Well, the dot product is nothing more than taking two vectors, like v1 and v2, multiplying their x's together, multiplying their y's together, and adding the two together. And then you're dividing it by the magnitude of the two vectors. So let's try this with these 2 points. We're going from 2, 4 and negative 5, 3. So we got one going out here to 2, 4. Okay, there's a vector going that way, and we've got one going negative 3, negative 5, going out this way. Okay, it looks like it's a pretty big angle that we're looking at there, probably more than 90 degrees. Okay, so let's first of all take the dot product. 2 times negative 3 is a negative 6. 4 times negative 5 is a negative 20. So I'm going to find the magnitude of this first one. 2 squared, 4. And 4 squared, 16. So that's, well, let's see here. 16 and 4 is 20. That's where the square root of 20 comes from. This other one, 9, 25. 9 and 25 add together to give you 34. So I've got the square root of 20 and the square root of 34. Multiply those together, I got square root of 680. So I've got negative 26 divided by the square root of 680. And that's what my cosine of theta is going to be. So when I divide this out, okay, I'm going to get when I divide that out and take the inverse cosine, that's what this is supposed to be. It's supposed to be an inverse cosine. The inverse cosine of negative 26 divided by square root of 680, I get 175 degrees, 175.6 degrees, almost 180 degrees. Seems reasonable, okay? That's the way you find these. It's not that difficult to do. Okay? So, a vector with an angle of theta. Okay? If you look at it from the origin, if you find the magnitude of the vector times the cosine of theta, comma, magnitude of the vector, cosine of theta, or sine of theta, that's where the point will be located. Okay? So if you're given the fact that it's 3 cosine of 15 degrees and 3 sine of 15 degrees, you should be able to use that information to find the x and the y coordinates for that particular vector. Okay? Going from the origin to that point. Cool. Okay. Where it starts getting tough is when you start looking at the magnitude of when you're looking at one vector going off this way and another vector going off this way, and they're wanting to know how much of a shadow this one is casting on that one. You're looking at the right angle right there. You're not looking at the x and the y coordinates any longer. You're looking at that right there. What you have to do is you have to take the dot product of the two vectors. We'll call this one v and this one w. Okay? And this is the w is the one that it's casting the shadow on. So you take the dot product of v and w divided by the magnitude of w. So let me give you an example. I've got this vector going through the point 2, 2, and a vector going through 9, 3. Dot product between the two. 2 times 9 is 18. 2 times 3 is 6. 9 plus 16 is 24. So let's find the magnitude. 2 squared plus 2 squared is 8. 2 times, let's see here, 2 squared is 4 times 2 squared is 4. And 9 squared is 81. And so I didn't need that point right there. 9 squared is 81 plus 9 is going to give me a 90. So I got the square root of 90 here. So 24 divided by the square root of 90 is 2.53. My magnitude of my projection is going to be 2.53. Okay? So if we use this, we take 24 times the square root of 90 times 9, and 24 square root of 90 times 3, we'll get 2.4 and 0.8. That's going to be the vector here, right there. 2.4, 0.8. That's how you can find that. That's the projection of this v vector on the w vector. That's how that is done. Okay? So I'm using this as my Class Connect, also using it as the 4.3 lesson since I won't be available for that day. So there's my secret word, walk. If you're watching this, please send me a K-mail telling me that you watched this, and I'll give you credit for having watched the Class Connect. I'll talk to you next time.